All right. Good morning. Gonna make this video to do the 7D Part 2 notes for pre-AP. This is some interesting stuff that sort of extends on a unit circle. We'll talk about this stuff with degrees and radians. For right now, we'll just keep the things in degrees to sort of make it simple for ourselves here. Okay, so let's see. All right. So let's suppose the radius of the circle is 1 unit. So like we have our unit circle here, and let's suppose the radius is 1 unit. So all these line segments here are 1 unit long. All right. What we can do is we can use some trig to find the coordinates of each point on the circle. Okay. Now I want to see how we sort of do this here. Okay. So we're going to look at the 30-degree radius and sort of follow along here. All right, to find the coordinates of these points. Okay. So we have our 30-degree, which I'm going to outline here in pink. All right. And so our 30-degree point is going to be right here. Okay. And what's going to happen is we're going to have a right triangle right there. And so our 30-degree point is going to have an x and a y value. Okay. An x and a y value. All right. So we make this little right triangle here at our 30-degree thing. Okay. Now, we know that the radius is 1. Okay. So the hypotenuse of this triangle is 1. Okay. So we have a right triangle here with a hypotenuse of 1. Whoops. Hypotenuse of 1. We're here and we have a 30-degree angle right there. Okay. Now, what's going to happen if we look at this thing here? So the opposite leg, which is this leg right here, is really going to be the height of this triangle. So the opposite leg here is going to be really your y value. Okay. The opposite leg is going to be your y value. And the adjacent leg down here is going to be your x value. You see that, the adjacent leg is horizontal, the opposite leg is vertical. So that's the adjacent leg. All right. And this is the opposite leg. Okay. So if we wanted to do some trig, all right, to find x and y, we can find our x and y values here with a unit radius of 1. Okay, so 1 is our hypotenuse. We know that. So if we wanted to find our x value, we're going to use our a, our adjacent, and our h is our hypotenuse. All right, which means we're going to use cosine. So what's going to happen here is I pull up my calculator. And we'll go under degrees for right now. Okay, we'll go under degrees. And we know that the cosine of our 30-degree angle is equal to our x value over 1. Okay? So our x value is really going to be the cosine of our 30-degree angle. Okay, the x value is going to be our cosine of our 30-degree angle. Okay? So cosine of 30, we can make sure we're in degree mode here. Okay. Okay, is 0.866. Okay, 0.866. So we come back up here. So our x value will be 0.866. All right. Now for our y value, so our y value is our opposite, right? So our y value is our opposite. So what's going to happen here is opposite is the y value, the hypotenuse is 1. So we're going to use opposite and hypotenuse, and then we're going to use sine. So the sine of our 30-degree angle, okay, is going to be our y value over 1. Okay, so what ends up happening is our y value is going to be the sine of 30. Okay, so we go back up to our calculator. All right, and we go sine of 30. Y value is going to be 0.5. All right, so we go back to our deal here. So at a 30-degree angle, all right, we have a 30-degree angle here. All right, so our X value is 0.866, okay, and our Y value is 0.5. All right. Now with that, we can also, you know, with the 30-degree thing right here, all right. And remember, 30 degrees sort of goes in this direction, but if we wanted to look at it from you know, the x-axis here, all right, there's another angle that's 30 degrees if we go from that axis up this way. So we might be able to find the coordinates of this point here at the 150-degree angle as well. Okay, we can also go 30 degrees down from the x-axis. So if we have a 30-degree angle coming down here, all right, we might be able to find the coordinates of that 210-degree thing, okay? And then 30 degrees going down this way. Okay, we might be able to find the XY coordinates at 330. Okay, so now that we have the XY coordinates at 30 degrees, all right, we might be able to find it where all the angles are some form of 30 degrees, just going in opposite directions right here. Okay, and so try that out, and then see if you can figure these four out, and then we're going to go on to the next one here, and then we're going to sort of tie some of this stuff together. Okay, so coming down. Now let's look at our 45-degree radius. We'll follow the video along here again. So let's say we have our 45-degree radius. I'll do this in this green color here. So 45-degree thing. So we're going to look there. Now remember, the hypotenuse is 1. Okay, so the hypotenuse is 1, and so now we have another right triangle here coming down like that. Okay, and again, we're going to have an X and a Y coordinate right there at the 45-degree mark. Okay, so now we have our 45-degree angle here, and we know our hypotenuse is 1. Okay, now the opposite leg, okay, again from the 45-degree angle, is our Y value. Okay, because it's our height. That's our opposite leg. Our adjacent leg is our X value. Okay, because that's the horizontal distance from here to there. Okay, so again, to find the X is the adjacent, 1 is the hypotenuse. All right, so X is the adjacent, 1 is the hypotenuse. So we got to use A over H, which is cosine again. So now we got to do cosine of 45 is equal to X over 1. Okay, so X is just equal to cosine 45. So here we go. We got cosine 45, okay, which is 0.707. We'll call it 0.71. So our X is equal to, 0.71. All right, we're looking at our Y value. Okay, for Y is our O, it's our opposite. H is our hypotenuse. Okay, so opposite and hypotenuse, we're going to use sine. Okay, so we know that the sine of our 45-degree angle is going to be equal to Y over 1. Okay, so we look for sine 45 equals Y over 1. So all we got to really do is type in sine 45. We do that. Sine 45, well, look at that. It also is 0.707, so we'll call that 0.71, which should make sense because this is an isosceles triangle here, ladies and gentlemen. Okay, because I have a 45-degree angle here, 90 here, so this angle up there is 45. So this is 45, then the two legs are going to be congruent. Okay, so X is going to be 0.71 and Y is going to be 0.71. All right, So at our 45 degree mark, we have 0.71, comma, 0.71. Now look at all the other 45 degree angles. If we start at our origin here and make some more 45 degrees, okay, we have a 45 degree angle sort of coming up here this way. Okay, just sort of in the opposite direction there. So we should be able to find where that point is, and we should be able to find, 45 degrees coming down here and 45 degrees coming down here. So there's a few other points where we could find that. Okay, now before we go, I want us to sort of look at something here with all these angles. Okay, so what happens here, ladies and gentlemen, is when we're looking at this unit circle, we saw from up here that, okay, our x value was the cosine of our angle. Okay, the x value was the cosine of our angle, and the y value was the sine of our angle. Okay, because again, the x value is the adjacent, the y value is the opposite. Okay, so opposite goes with sine, adjacent goes with cosine. All right, same deal here. Okay, so we have our x value was our cosine of our angle. Okay, the y value, okay, the y value was the sine of our angle right there. Okay, and so we should have gotten those points from that. So what we see is as we go along the unit circle, ladies and gentlemen, okay, and if we're looking for all those points, okay, the x, y value of all those points, ladies and gentlemen, is really going to be cosine, comma, sine. Okay, the cosine of our theta angle and the sine of our theta angle. Okay, whether we use the angles in radians or degrees, okay, you can, if you want to do the angles in radians, you can do it in the calculator and just switch to radian mode. We could talk about that later on, but I want you to sort of see how, the x and y's on all this thing are going to be the cosine of our theta and the sine of our theta. Okay, and so now that we did the 30 and the 45, okay, really we only just did these two in the video. Remember, we did the 30 degree angle up on the first page, okay, with that color right there, and we got the points for there. So with these coordinates there and this coordinate right there, we should be able to find, ladies and gentlemen, the coordinates for every one of these going all around the circle. Okay, so we should be able to find the x, y coordinates for all those. So that's what I want y'all to do here on the surface page. See if we can fill out the x, y coordinates for all the other angles on the unit circle here. Okay, using the first two, we should be pretty cool. All right, and then we should be able to fill out a good chunk of this table down here. We'll talk about that more sort of at the end of the period. Okay, so that's our 7D part 2 notes for pre-AP. This sort of dips into some pre-cal stuff, but I thought it was kind of cool. It's sort of a cool way to sort of tie together the stuff that we've been doing with the unit circle and degrees and radians and the like. Okay, so that is that, and we'll talk if we have any more questions. And you guys have a terrific day.